In this tutorial, we're going to learn how to record and display forces on moving and static objects. Let's start with a simple example. I'm going to start by creating a static body, and let's make it a cuboid tank. I'm going to resize it to be 1/2 meter along each edge. And I'm going to change the display setting to wire so that we can see inside of it more easily. I'm going to add 2 more static bodies to this tank. Here is one cuboid, and I'm going to go ahead and change its dimensions to 5 centimeters by 1/2 meter, and let's make that by 5 centimeters again. And then I'm going to translate it to the side slightly. Then I could just make a new static body, but actually an easier way would be just to clone the static body that I already have. And I'm going to change its location to the other side of the tank. And I'm going to right click on the names and rename them. One of these I'm going to name Cuboid Coarse, and the other one I'm going to rename Cuboid Fine. Something to keep in mind with adding bodies to a simulation is that they are going to be given automatic mesh settings. So now I can change those settings by selecting the family and then going to more and then editing mesh. Changing the mesh resolution will not strongly inform the fluid mechanics, although improving solid body mesh quality will improve the detail of any solid force distribution generated by the solver. And I'll show you more about this later in the video. I'm going to leave the mesh settings on this cuboid on the default, and then I'm going to edit the mesh settings on the fine cuboid. As we can see, we have a fast setting, which is extremely coarse, as you might expect. And then we can incrementally set the coarseness to finer and finer. I'm going to use the ultrafine option. Now let's add some moving bodies. Let's start with the classic parametric Rushton. And like I did before, I'm going to rename this one as a coarse Rushton. And I'm going to remove the shaft. And make it a little smaller, just so it fits inside a little easier. And going to move it down on the y-axis a little bit. Or actually, let's move it up. Now I've cloned it, and with this one I'm going to rename it as Rushton Fine. And I'm going to move it down on the y-axis so that we can see both of these moving objects. Let's start by looking at the mesh settings on the coarse Rushton. So as we can see, that's the default setting. And on the fine Rushton, we can see what ultrafine looks like. But you also can set a custom value. So let's see what 002 looks like, and that looks good. Again, these solid body resolutions will not strongly influence the predicted flow field, power number, or total forces on the impeller. The higher resolution will affect, however, the level of detail on spatial variations in the force and pressure across the surface of the solid objects. I will re-emphasize this point later in the video. We also need to adjust some simulation parameters. So max runtime, 10 seconds is plenty. Resolution 150 is good. And we also need to make sure the output settings are going to give us everything we need. Let's set the write time interval to 0.01 seconds. Let's enable vorticity magnitude under volumes and output forces for these two static objects. And then the moving bodies, the output forces will come automatically, but we also want the time average. Now that we have all of this set up, let's run the simulation and take a look at the data we get. It looks like the simulation has finished successfully, and let's start it in post to take a look at the results. Here is our cuboid tank with our objects inside of it. I'm going to go ahead and turn off the visibility of the tank walls, as well as the velocity fields. They look pretty cool, but that's not the data we're really interested in right now. Let's start by looking at the shear stresses on both of these Rushton turbines. And you can click this button and select a color scale that you like to make it look pretty. And it often helps to drag down the chart to decrease the maximum a little bit. Now we can see the shear stress distribution on both of the impellers. We also can see a difference in the resolution between this Rushton that had the default mesh settings and this Rushton that we customized to have a much more refined surface mesh. I'm getting the highest values on these corners, which is what I would expect. And it looks like there's some kind of trailing vortex that's impacting the Rushton as it moves. I'm going to press play and watch the simulation run and see how these forces develop. We also recorded the time averages. Let's go ahead and take a look at that. I'm going to select a color again and decrease the max just so I can see the colors a bit better. We can also see the much finer resolution on the lower Rushton. Now let's divert our attention away from the moving objects and take a look at the two solid cuboids. It's pretty much going to be the same procedure as before. Let's take a look at the shear stresses on each of these cuboids. I'm going to use this double arrow button to rescale the data and press play to watch what happens. What this is telling me is there's two kind of distinctive structures impacting these cuboids, which makes me curious to see exactly what those are and what they look like. I'm going to take a look at the time average data for the cuboids. And I'm going to reduce the maximum by dragging the bar down. Oh, oops, looks like I went a little too far. I can drag the bar to the right and decrease it. Now, before we dig into this a little deeper, let's take a look at the cuboid with the coarse resolution. And you can see it's hardly picking up any of the data, which tells me that there really wasn't enough resolution to begin with to resolve these structures. Now we want to see where these structures actually come from. I'm going to start by switching into 3D mode. Like I did before, I'm going to turn off the tank walls Here you can see the velocity field. But we still can't quite see the structures on the cuboids that we are looking for. But since we recorded the vorticity magnitude, I can show you a really simple way to model the trailing vortices on a rotating Rushton. Now we can see pretty clearly the vortices behind each of the impeller blades. Looks like there's two behind each impeller blade, and it looks like these structures are rotating. We can make these structures even more visible by using a contour filter. We need to select the vorticityism again as an input. And I'm going to start inputting some values to see what will give me the best result. So that looks good, but let's try this one. Now we can see these structures pretty easily, and I'm going to color these by velocity magnitude. Like I've done before, I'm going to pick a color. Now we can pretty much see exactly what's going on. We can see these rotating structures coming off the Rushton. We also can see the high velocity centers where the two rotating flows are meeting together and combining. This red section, we can really see those high velocities on the inside. Now let's turn, wrong thing. Let's turn on the time average shear stresses for each of the cuboids again. And picking a color, reducing the maximum as we've done before. Now let's re-enable the movement of the vortices we saw earlier. And now we can see very clearly that the structures impacting the cuboids are in fact trailing vortices coming off of the rotating Rushton. Now let's say I want to make a nice image or picture for a presentation or something. I can click on this icon in the top left called Enable Ray Tracing, and it's going to generate a really nice rendering for me with light and shadow and other features. If you notice, the impellers are invisible right now, and that's because they have a material surface setting. Right now they're set to mirror, and I can change that to let them appear in the render. This always takes a couple seconds to render properly. I could also use some different colors on the Rushtons. For example, I could use the coloring for the shear stresses on the Rushtons. But when I do that, they don't actually show up because the material of the Rushton will override the color I set to it. If you want those colors, it's a simple process to turn off the material, which will allow those forces to be shown with those colors. Thank you for watching this video on predicting forces on solid surfaces in MStar CFD. Please reach out if you have any questions.